boundaries. What's the difference between a class boundary and a class limit? This is not coming from a data set. But suppose we had a few classes. I'll just take a few for the moment. Now, this is fine if we're working with discrete data. The key here is the difference between discrete and continuous data. Discrete data, remember, there's a finite amount of accuracy, either naturally occurring or sometimes we choose to limit how accurately we measure things. But we do have to recognize that the original data was continuous, and later on in this semester that will become relevant. So, drive-through times, for example, we choose to measure them to the closest second because, well, to be honest, why does it matter tenths or hundredths of a second when you're going through the McDonald's drive-through? So we choose to give it a natural limitation there. There are some instances where we might actually want to pay attention to those values in between the data values. So if we're dealing with discrete data, a class like this is fine because we might have a 5, we might have a 6. But if we're dealing with discrete data, we should probably not ever have a 5.3 or a 5.72. But what if we could? Or what if we chose to measure to that level? Values like that wouldn't have a home here. Think of it like this. Let's look at a number line. Think of it like this. The class from 1 to 5 stops at 5, which is fine because we would only have 1 or 2 or 3 or 4 or 5 with discrete data. Now, we don't have to make any changes if we allow for continuous data as far as inside the group goes. Certainly, if we're including 1 and 2, we should be able to include anything in between them without any adjustments whatsoever. The value 1.6 would clearly still fall in between 1 and 5. The question is, what happens when we get values that are between two of the classes? The next class, 6 to 10, would start over here. And we have this gap in between them that doesn't fall into either class. Again, the gap here is fine. It's still within this class. The gap between 2 and 3 is still within this class. But the gap between 5 and 6 is not in either class. So what we kind of do is we stretch out each side of this until they meet up in the middle. We kind of stretch it out until they meet up in the middle. That is called a boundary. A class limit is what we use to denote the ends of each class for discrete data. Boundaries give us limitations for, or boundaries if you will, for continuous data. Now, there is something we have to take into account, and that's that this is not the only gap between classes. There's another one. So if I may, I'm going to redraw this number line so we can see all 3 classes. So we have a class from 1 to 5. We have another from 6 to 10, and another from 11 to 15. Now these classes, and the number line is nice because you can actually get a visual for it, these classes are all the same size. Well, if you'll excuse the fact that I'm not really an artist here, they are at the same size. So, what we saw before was that we kind of split the difference between these, found exactly the middle, 5.5. We kind of stretched out each side until they met up in the middle. What we've actually done is we've actually made this class bigger. It actually extends, it visually stretches out further, and same with 6 to 10. It actually stretches out further. Well, that means the classes are not all the same size because this one has not been stretched at all. Well, we have that same gap problem, so if we stretch each side of the gap together and we pull them together until they meet up in the middle at 10.5, well, now we've fixed that. We've kind of unbalanced it again though. The middle class has been stretched in both directions. The first class has only been stretched on the right, and the third class has only been stretched on the left. So again, they're not exactly the same size here. So this part is a little bit odd, but it does still follow. The idea here is that we're stretching by the same amount on each thing. This got stretched out by 0.5, and this side got stretched out by 0.5. This side got stretched out by 0.5, and that side got stretched out by 0.5. If we want to keep everything uniform, I know there's no class over here, but we still need to stretch out by 0.5. And the same thing over here. I know there's no other class, but if we want to keep the classes we have the same width, we still need to stretch out by 0.5. So while these are the class limits, if we were to define the classes by class boundaries, it would be from 0.5 to 5.5. From 5.5 to 10.5. And from 10.5 to 15.5. Now, an interesting kind of question always comes up here. What if we get 10.5 exactly? Which does it go into? Well, remember that this is being done for continuous. We're supposed to account for all possible decimal values. Now, obviously, anything smaller than 10.5 would go down to this group, and anything bigger than 10.5 would go into that group. But class boundaries are very often represented by an interval of values. This class boundary can be denoted using interval notation, as you would have seen with inequalities in an algebra class. And the way we keep them from overlapping is that we always include the lower limit and exclude the upper limit. That way, everything that goes up to but not including 5.5 would be in the first class. If we actually had 5.5, it would be included in the next class. The second class then would go up to but not include the 10.5. And the last class would include the 10.5. And then go all the way up to but not including the 15.5. Now, as it turns out, for the very beginning and very end, it doesn't really matter for those that we are including that and excluding this one, because again, the data values themselves won't actually be there. We extend it at the very, very left and the very, very right, only for the purposes of keeping the classes the same width. We would not actually have to worry about that particularly, because if there were data values over here, we would have not had our first class limit be 1. Our first class limit is 1 because that was the first data value. So we acknowledge that by saying the lower class does not include it, and the successive class does always include that boundary point. Class boundaries are, again, they're a way of kind of bridging the gap between discrete and continuous data. Purely discrete data that literally cannot be measured beyond a certain level of precision, we would never have to do that with, because we would literally never have anything between 5 and 6. Because in purely discrete data, that actually doesn't happen. However, most data is technically continuous, and we simply choose to limit how accurately we measure it. Like the drive-through times, for example. Could we measure the drive-through service times to 1/10 of a second, or 100th of a second, or 1,000th of a second, or even further if we wanted? I suppose, but why would we want to? So we choose to limit that, but in theory we really could measure it. So in theory, there are some data sets where we could, in theory, measure in between the values to any level of precision. That will actually become relevant later in the semester, because eventually we're going to have to deal with the fact that technically continuous data really is continuous and should be treated that way. While we may measure it discretely, it must be treated and dealt with in a continuous fashion, eventually. So, class boundaries are not of a particular concern at this point, and this is a very, very rare instance where I will tell you it's not something you need to worry yourself too much about. I tend not to ask about class boundaries until much later in the semester. However, they are included on many of the homework problems, so I did want to make sure that you see them now and get the exposure and the definition. We will revisit the concept later when it becomes relevant. For now, you will need to know about class boundaries for the purposes of the homework. But I will, again, a rare instance here, I will tell you, class boundaries will not be on the first test. They will be on a later test, but not on the first.